Welcome students to this screencast regarding scientific notation part 1, where we'll get a definition of scientific notation and begin to work with it looking at the distance that Earth is from the Sun. So let's go ahead and get started. First off, we need to start with a definition. What is scientific notation? Well, scientific notation is a way to express a very large or very small number as the product of a number between 1 and 10 and a power of 10. And I want us to focus in on the idea that this is a product. Scientific notation is a product, so we need to keep that in mind. Then we also need to understand it's the product between a number that's between 1 and 10 and then a power of 10. So a number between 1 and 10 and a power of 10. So written in general, it would look something like this: A times 10 to the n power, where A has got to be greater than or equal to 1, but yet less than 10, and n is some integer. All right, so n is some integer. All right, so we've got that now. A times 10 to the n, where A is greater than or equal to 1, but less than 10, and n is some integer. All right, so let's take a look. What does this mean to us? Well, if we look at, for instance, how far is the Earth from the Sun? Well, the Earth is 92,960,000 miles from the Sun. And I went ahead and double-checked Google, went to NASA. They said about 93 million miles. So we're going to stick with this number here and write it in scientific notation. So let's take a look. Let's go back to where we had started. The Earth is 92,960,000 miles from the Sun. So how would we write that in scientific notation? Well, let's go back to our definition. Our definition says that scientific notation is a product of some number, let's call it A, times 10 to some power. And A has got to be between 1 and less than 10. So really between 1 and 9. Or 1 and 9.99. Okay, a 9.9999, however many nines are after that. So let's take a look. If we want to write this in this fashion over here, then we're going to need to move this decimal 1. Just pretend there's a decimal there. We're going to need to move it 1, 2, 3, 4, 5, 6, 7 times. Notice, we've moved it all the way to the point where now 9 fits the definition of fitting between 1 and 10. So to write this in scientific notation, we'd write 9 point. Now we can't forget about these numbers right here. These are important to us. So we're going to keep them. All right? You're going to notice in a second, these zeros are going to seem like they disappear, but they really don't. But these numbers are important. We want to hang on to those. So 9.296, that's our A. Now times 10. Well, how many times did we move that decimal point? Let's count it again. 1, 2, 3, 4, 5, 6, 7. 10 to the 7th power. Notice that 7 represents moving that decimal 1, 2, 3 times plus these 4 zeros that we had up here. Because ultimately when we have a 0 in front of the decimal point, that's just a tens place, if you will, or a multiple of 10. So tens, hundreds, thousands, 10,000, so on. Well, we're just multiplying by 10 each time to get these zeros in this number. So there we go. We took a number written in what we would call standard form up here, and we wrote it in its scientific notation form. And that's the distance that Earth is from the Sun. Check out video part 2 as we apply some more problems to scientific notation.